Hello everyone. In the last class, we have discussed about how to arrange the numerical data in the tabular form. But there we have dealt with a limited number of datas. What if there are a large number of datas? Then in that case, we cannot represent each and every data in a tabular form because then the table will be very long. So in order to solve this, today we are going to discuss the topic called grouping data. We have to group them. Say there are a lot of students, say 100 students in a class. If you have to write down the details of each and every student one by one individually, then it will take a lot of time. Also it will be a really hectic job to do. So instead of that, if we group them according to some of the common characteristics, then in that case the data becomes much more systematic, as well as it is very easy to find out the result. So that's all we'll be discussing in the grouping of the data. So how to group the data? Let us see. When the number of data is very large, then we cannot represent them in a simple frequency distribution table. Last class we have discussed about the frequency distribution table. That was a simple one. But what if there are large number of data? Then we can't, as I've said a while ago, that we cannot represent each and every data individually then. So rather we have to group those data and then obtain a frequency distribution of the number of data falling in each group. Clear? I have given you the example just now. So accordingly we will group them. Now for example, as usual, we will start with the help of an example for better understanding. Say for example, there are 60 students in a class and there was a test taken on mathematics. So out of 50 marks. So now if you have to represent this data in a tabular form or whatever form we want. So 60 students, it is a lot number, is a big number. So we cannot write 60 entries in the table. It will be a very long table. You just imagine it. So instead of that, we have to group these 60 students according to their marks obtained. So what we'll do is that you can see here, this is the question, lot of data as you can see. If you have to write each and every data singly, individually in a table, the table will be very long. So now we will be grouping this. So what we'll do is that we will now group the data in the groups. We have made a range, you can say, a group, say 0 to 10, 10 to 20 and so on. So 0 to 10, these are the marks range, you can see. Within this range, how many students fall? From 10 to 20, how many students fall? All this we will be grouping them. So, and then we'll tabulate them in a frequency distribution table. The table will be same as it is, but here only one thing has been added additionally, that is groups. So we'll be seeing let us see what is how the group look like. So this is the table. So similar like the last table, last frequency distribution table, tally marks are there, frequency is there. We all know what is these two things. Only additional feature here is the groups. We have grouped them. So 0 to 10, how many students got the marks? 2 students. 10 to 20, how many got? 10 students. 20 to 30, 21. 30 to 40, 19 students. 40 to 50, 7 students. 50 to 60, 1 student only. So if you'll tally, and one interesting fact is that if you'll take the sum of all these frequencies, you will get the total number of students. So if somehow this total number of students is not given to you in the question, only the frequency, this thing is given, then if I ask how many students are there, total number of datas are there, you can say. So if you add all these frequencies, you will get the total number of datas available. Clear? Now let us now describe this table itself. Now the data represented in this manner is said to be grouped. You can see groups are used here. So it is grouped. And so the distribution table name was also changed. Now it is called grouped frequency distribution table. Clear? Now each of the groups have this, you can see the groups 0 to 10, 10 to 20. So what are these called? They have a particular name. They are called class interval. Clear? They are called class interval, or simply you can say class. Say class 1, 2, 3, 4. Class 1 students will not be sitting in class 10. Clear? So because they fall in that category, in that group, so they will go into that group. So similarly, they are also called class because they fall in that group, in that category. Clear? Now there are some conventions, or you can say some procedures that has to be followed while putting them or putting the data in a particular group. We just can't put them as we like. We have to follow some rules, you can say, some procedures. So that is called convention. So what are those conventions? Let us see. Now a data cannot occur twice in both the groups. Yes, that is very clear. You cannot be a student of class 8 also. You cannot be a student. You can be at the same time you can be the student of two classes. Can it be? No. You cannot be the student of class 8 as well as class 7. This can't happen. You have to be a student of only one particular class. Similarly here, a data cannot occur in two classes or two class intervals. It cannot happen. Say for example, you have taken here 10. Why I have taken 10? There is also a reason behind it. Why I have taken 10 here? Because 0 to 10, there is a range, or you can say a class. Then as well as there is 10 to 20. Now you might be confused where to place this 10. We will place it here also and here also. No, it can't happen, as we have already know that one data cannot occur in both the classes. So where to place it? So here we have to use some convention or some rules. What convention we'll use is that whenever such a situation arises where one data falls in both the categories, then we will choose the, or we will place the data in a higher class. That is in this class, 10 to 20, and not in 0 to 10. This is one convention. This is one rule. Whenever such situation arises where this term is common in both the classes, then what you have to do, you have to place it in the higher class. Clear? Now next, in the class interval, say 10 to 20, all those data which are between 10 and 20, including 10, will belong to the class interval 10 to 20. The data 20 will not belong in the class interval 10 to 20. Yes. All those data, 10, 11, 12, 13, 14, 15, 16, up to 19. All those data will be included in this class interval, but not 20. 20 is excluded. Clear? Just like here, in 0 to 10, which data will be there? From 0 to 9. 10 will not be included here. 10 will fall in the next higher class, according to the convention. Similarly, if you will have to say 20, where it will fall? It will fall in the class 20 to 30, not in 10 to 20. Clear? In the next class, next higher class it falls. Clear? And other rest of the data from 10 to 19, it will be falling in 10 to 20 class interval. Clear? Now next, in the class interval say 10 to 20, 10 is called what? It is also having a particular name. It is called lower class limit, and 20 is called the upper class limit. So we can say that in any class interval, all the data from the lower class limit, it goes up to the data which is just before the upper class limit, but the upper class limit will not fall in that class interval. Upper class limit will always fall in the higher class interval. Other than that, all the data within that class interval will fall in that class itself. Clear? Now the difference, you can see 10 to 20, this class, you can say the range also, you can say. So this difference is between the upper class limit and the lower class limit. It has a particular name. It is called width or size. We also sometimes call it range, but the word range is not used here. It is used in statistics. So, but here we will be using the name width or size. What is the size? So if you are asked what is the size of the class interval, then it is a difference between the upper class limit and the lower class limit. Clear? Now next topic is bars with difference. So what is bars with difference? In the last class we have discussed, mainly in the first class itself, we have discussed what is this bar graph, double bar graph, all these things. So here also we will discuss some of the bar graphs. So let us see. Let us consider the grouped frequency distribution of the marks obtained by 60 students in a class maths test. Same thing we have. that same table which you have seen in the last slide. We'll discuss that only. So this is the class interval and this is the frequency. We all know, this much is clear to you. Very simple. So how to represent this in a bar graph? So you can see here, we already know what is a bar graph. But here, this bar graph is little bit different in nature. You can see here number of students, it is well known, and here the marks of the students, it is also well known. But since these class intervals are continuous, so there will be no gap between these bars. You can see here in this graph the groups are these things are already known, which is where. But since the class intervals are continuous, so the bars also will be continuous. There will be no gapping. Just like in the earlier case, in the bar graph or the double bar graph, there are gaps of equal width. But here there will be no gaps. Clear? So this is the difference. And the rest of the thing is as it is. The frequency will determine the height of the bars. There is no gap between the bars as there is no gap between the class intervals. So that is a simple thing. Now the graphical representation of the data, this type of graph is called, it is a new name you can say, a histogram. So this type of graphs, bar graphs you can say, are called histogram, where there is no gapping. Clear? The rest of the thing is same as it is like bar graphs, but there is no gap just here because the class intervals are continuous. So this is also another type of a bar graph. Only the difference is that here you can see here no gaps in between. Heights are determined by the frequency, and there is a little bit of jagged line you can say. This is called jagged line. Little bit of curve type of thing, a spike you can say. So why is this jagged line? You can see it directly started from 20, but as we know from 0 it cannot directly go to 20. The range should be equal. Here it is 0 to 20, then how come here it is 20 to 25? And then again the gapping is 5, 5. No. So that's why we have used the jagged line. Because there is no data or no frequency in between 0 to 20. It has started itself from 20. So we have given a jagged line. That is the difference. You can see here, indicate that we are not showing the numbers between 0 to 20. Means there is no data in between 0 to 20. So as a result, we have used a jagged line. Clear? So that's it. I hope you all have understood it. You can again go back to your textbooks and see for yourself. You can try out some examples are given already, solved examples. You can try it out for yourself and see the difference between these graphs, the different types of graphs, bar graphs, double bar graphs, this histogram and all these things. So that's it then. Thank you and have a nice day.